Hi, this is King of Review. Here we have an inequality to solve, and one of the first things I notice is that one log in this inequality has a base of 4, while the other has a base of 2. But let's use an important property of logs, that if I have a log base b of x, and I want to, let's say, square that base, since I know 2 squared is 4. If I square the base, b squared, I also have to square what's inside the log, x squared. Using that property, I can rewrite this inequality as the log base 4 of x squared minus the log base 4, so now I have squared my base from 2 to 4, of x squared. I squared the term inside the log as well. Now this would be very nice if both of these terms were based on the log base 4 of x. We need to do something about this squared, though, which is inside the log base 4 in the second term. There's another nice property we can use for logs, which is if you have the log base b of x to some power a, you can take that power and move it in front of the log, and it becomes a times the log base b of x. Applying that to this problem, we have the log base 4 of x squared minus 2 times the log base 4 of x is less than 0. Now that I have the log base 4 of x squared and the log base 4 of x by itself, it might be easier to introduce a variable y and set that equal to the log base 4 of x. Now I can plug y in every time I have log base 4 of x in my equation, and this is a much easier problem to solve. I can factor out a y and see that I have y times y minus 2 is less than 0. If this product is negative, less than 0, that either means that y is less than 0 and y minus 2 is greater than 0, or the other way around. Y is greater than 0 and y minus 2 is less than 0. Well, let's see, adding 2 in these two inequalities gives me y is greater than 2 and y is less than 2. Now on the left side, we have that y is less than 0 and also greater than 2. But there are no numbers that can be in both of those places at once, so this solution will not work. On the right side, we have y is greater than 0 and y is less than 2. That is certainly possible, to be greater than 0 and also less than 2. And so here is our solution for y. 0 is less than y, which is less than 2. But now let's put this back in terms of x. We have 0 is less than y, but y here means the log base 4 of x, which is less than 2. Now all we need to do to solve for x is get rid of the log base 4. We can use the fact that logs and exponents are inverses, so our third property we need is that if you raise a number b to the log base b of x, the log and the b, that's the base of an exponent, cancel out and we're just left with x. Since 4 is the base of the log, I need to raise 4 to the power of all three parts of my inequality. 4 to the 0 power is 1, 4 to the log base 4 cancels out, and I'm left with x, and 4 squared is 16. So here is my solution for x, and I've discovered it must be b. And that's it. Thanks for watching.